Section 5.3 is going to talk about inequalities in just one triangle. We'll get to a section here where we talk about inequalities in two triangles, but today we're just going to focus on simple inequalities in one triangle. Starting up here at the top where it says a review of a few algebra properties, here is just some I call them common sense. So in number one, okay, if A is greater than B, if you add C to both sides, it still stays the same, right? A plus C is greater than B plus C. For example, if I have 3 is greater than 2, and then I add the same thing to each side, okay, that inequality right there, that sign still holds because it's 4 is greater than 3. Okay, that's kind of the principle behind all of these statements up here, 1, 3, and 5, as well as 2 and 4. Now, moving beyond that, we're going to get to a couple theorems here right off the bat. Your first theorem is theorem 551, and this is one of the two angle-side relationships in triangles. Here's what we know about a triangle in 551. The largest angle in a triangle is opposite the longest side. Okay, largest angle opposite the longest side. And then if we flip-flop that, the longest side in a triangle is opposite the largest angle. Okay, so it works both ways. If all you have are angles, then you can look and you can say, hey, this is the longest side. If all you have are sides, you can say, hey, look at this. This is the biggest. These are how my angles are ordered from least to greatest. Which is what we're going to do here in our first example. List the angles in order from least to greatest. We're given the sides. So this goes with theorem 552, given the sides, find the angles. Okay, so 9 centimeters, this is our longest side. That means S is our largest angle. Okay, and then I'll color code this. All right, 7 is our next longest side. That means R is the next largest angle. And then 6 is our smallest side. So T is our smallest angle. So in order from greatest to least, your largest angle is angle S. The middle guy is angle R. Your smallest angle is angle T. Gets a little bit easier over here, okay? Well, actually, we're going to list the sides. Sorry, I thought we were going to list the angles, least to greatest, but that'd be silly. Here we're going to list the sides in order from least to greatest, or I'm sorry, from greatest to least. Your biggest angle is 125 degrees, so that means AC is my longest side. Then our next largest angle is the 35 degrees. That means AB is our next longest side. Angle A is our smallest angle. That means BC is our shortest side. Okay, example A and example B, you might want to pause and try them on your own, and then come back to the video and see if you can get the right answer. Check your answers with what I have written here in example A and example B. Now we're going to move on to our next theorem called the exterior angle inequality theorem. Here's what the theorem says. The measure of an exterior, and I'm going to abbreviate here, exterior angle is greater than the measure of either of its corresponding remote interior angles. We had a remote interior angle theorem in the last unit, okay, so we're kind of expanding on that. But, you know, if you're a little confused or don't quite remember exactly what a remote interior angle was, okay, angle 1 is an exterior angle. Its remote interior angles are the 2 of the 3 angles of the triangle that don't touch it. Okay, so the 2 angles that don't touch angle 1 are angle A and angle B. So angle A and B are the remote interior angles of angle 1. Now, here is what this theorem says. Okay? This theorem says that the measure of an exterior angle, so in this case, exterior angle 1, is bigger than angle B. Angle 1 is also bigger than angle A. That's what this theorem says. Okay? So now let's write all that out. What is the exterior angle? It's angle 1. The remote interior angles, angle A and angle B. And according to this exterior angle inequality theorem, the exterior angle has to be greater than both of its remote interior. So there's two statements to make. Angle 1 is bigger than angle A. Angle 1 is greater than angle B. So now we can take this and we can use this to say in any given triangle, when we have, angles numbered like this, which angles are bigger than other angles, which angles are smaller than other angles, based on this exterior angle inequality theorem. Okay, so first of all, number 1, all angles whose measures are less than the measure of angle 1. Okay, well, angle 1 is an exterior angle. An exterior angle is guaranteed to be bigger than both its remote interior. So its remote interior are angle 3 and angle 4. Okay, so angle 1 is guaranteed to be bigger than both of those. Moving on. Number 2, all angles whose measures are greater than the measure of angle 3. Well, let's see, where's angle 3? Okay, angle 3 is an interior angle. So angle 3 is going to be smaller than its exterior angle. Okay? All right, so what is 3 is a remote exterior angle of what angle or angles? Angle 1 is outside and doesn't touch 3. Angle 5 is outside and doesn't touch 3. Okay? So 1 and 5 have 3 as one of its remote interior. So 3 is guaranteed to be smaller, which means angle 1 and angle 5 are guaranteed to be bigger. Number 3, guess what? There's a repeat. We already did this one. It's the same thing as number 1. Okay, number 4, all angles whose measures are greater than angle 1. Okay, now let me do this. We got to change figures here. And now we're focused on this figure right here. Okay. All right, angle 1. Okay. Angle 1 is right here. Now, angle 1 is greater than any of its remote interior angles. Now, it looks funny because it looks like 1 is an interior angle, and it is for one of the triangles. But it's an exterior angle for triangle UWV. So in triangle UWV, all right, there's 2 remote interior, 5 and 6. So 5 and 6 are guaranteed to be smaller than 1. Does that answer the question? It doesn't. Okay. So if we shift gears here, and instead of looking at 1 as an exterior angle, let's look at 1 as an interior angle of that triangle right there. Now, 1 is a remote interior angle of angle 7. So angle 7 is guaranteed to be bigger than angle 1. Is that what we're looking for? Yes. Angle 7. Now, all angles whose measures are less than the measure of angle 7 would be whatever are the remote interior angles with exterior angle 7. Well, angle 1 is one of them. Angle 3 is the other. Now, you might want to pause and try 6, 7, and 8, and then come back to the video and see if you're right. Check out 6, 7, and 8. There's your answers. As you turn the page, 9, 10, and 11. Okay, our kind of review, okay, we're kind of jumping back to what we started with to see if we still remember what we talked about in terms of where our longest sides are compared to our biggest angles and vice versa. All right, so take a minute, okay, pause the video and see if you can do 9, 10, and 11. Here are the answers for 9, 10, and 11. Check them out. Now, our last theorem of the day, okay, the triangle inequality theorem. Okay, the triangle inequality theorem says the sum of the lengths of any two sides of a triangle is greater than, okay, is greater than, not greater than or equal to, is greater than the length of the third side. That's the only way that you can have a triangle, is if for all three of the sides, if you add up every two and it's bigger than the third, and you've got to check all three combinations. And if all three combinations hold true, okay, or keep this triangle inequality theorem true, then you can have a triangle. For example, in number 12, okay, in number 12, right, here are the lengths of the sides of our triangle, 2, 3, 5. So if you drew a triangle, 2, 3, 5, okay? Right, so I add up two of the three sides. So I'm going to go 2 plus 3. Is 2 plus 3 greater than 5? No, it's equal to. So I'm going to put an X. Right, then I'm going to try the other combinations, okay? 3 plus 5, is that greater than 2? Yes. All right, and then 2 plus 5, is that greater than 3? Yes. All right, but guys, this combination of side lengths does not make a triangle because of this right here. We have to have a check mark on all three instances for us to be able to say that those are the lengths of the sides of a triangle. You'll see it happen here in 13. 5 plus 7 is greater than 9. Yes. 7 plus 9 is greater than 5. Yes. 5 plus 9, is that greater than 7? Yes. So these three would be the sides. We could construct a triangle, in other words, with the sides 5, 7, and 9. Now, try 14, 15, 16, and 17. Pause the video. And what you're trying to do is you're trying to see if all three, okay, all three of these instances are yes. If they are, your answer is yes. You got a triangle. If one of them doesn't work, all of them might not work. Two of them might not work. But if just one of them doesn't work, your answer is no. Try it out. Here's your answers for 14, 15, 16, and 17. Check them out. All right, now, the very last thing we're going to do is we're going to do this, and it's real similar to what we just did. This time, I'm going to give you two side lengths. And what we're going to do is we're going to find the range of values that our third side length could be for us to still create a triangle. Okay? So in this case, we're given the fact that we've got two sides. Okay? They've got the length, and I'll make this one a little bit shorter. Okay? They've got the lengths of 22 and 18. Okay? Now, we could have a range of values that this green side could be, right? We do. Because we could take the side, let's say that's equal to 22. Okay? And actually, I'm going to redraw this with different colors so I can do this animation for you. All right? Let's say that that's 22. That's 18. Okay? Now, the green side here, which is the side we're going to find a range of lengths for, could be that long. I take one of the sides and I say, hey, I want to rotate this. Okay? I want to rotate this Okay, and then I'm going to move it a little bit so I still have that vertex. Now, my green side's going to be a little bit of a different length, isn't it? Now my green side is only that long. So there's a variety of lengths that that third side could be. Here's how you find that range. If we list the lengths of our sides, okay, and here's what I always tell everyone to do. List the lengths, 22, 18, and then x. And x is what we're trying to find. You're kind of going to go through the progression like we just did up here, okay? If you take a look at 12, 13, 14, 15, 16, and 17, and you'll notice what I did. I did everything in the same order. I always started with the first two and saw if they were greater than the last number. All right? And then I took the last two numbers and asked if I added them together, were they greater than the first number? And then I said, okay, my last combination is I've got to add the first and the last to see if they're greater than the middle number. And I used that order every single time. So I'm going to do the same thing here. I'm going to take the first and the last numbers and see if they're greater than x. Now, we want to solve this, or we want to, it says, compute this. Okay? So what is 18 plus 22? It's 40. We never want to read an inequality like that. We always want to flip it. Okay? So x is less than 40. Okay? That's going to be as big as x can get. X is going to be less than 40. That's our ceiling. The next two, we're going to find our floor for how small x can be. All right, so now I'm going to add the first and the second number and see if they're bigger than the first number. And I'm going to solve this. So I subtract 18 from each side, and I get x is greater than 4. Okay. Now, that could be my floor. Could be. But I have to do the last combination. I've got to add the first and the last and see if it's greater than the middle number. Okay, so again, all right, I'm going to subtract 22, and I get x is greater than negative 4. Okay, so if we look at our numbers here, okay, if we look at our numbers, think about this. Can we have a side length that's negative? No, we can't. Okay, we can't have a side length that's negative. Okay, the other thing to look at is exactly what's said in the parentheses there. Okay, 22, this number right here, is already greater than 18. We don't need to add anything to it. It's already bigger. So this becomes a moot point. So we don't need to solve it. So our only two inequalities we need to deal with are these two. So what does that mean in terms of our range of values? X is greater than 4, but it has to be less than 40. And here's how we write that. Smaller number, variable, bigger number. And you use less than signs every time. Let's do another one. Okay. I'm going to go ahead and I'm going to do the one in the middle. Okay, 7, 14, and x. Add the first two, greater than x. Okay, 7 plus 14 is 21, so x has to be less than 21. Add the first and the last one. I'm sorry, let's stay in order. Add the second one and the last one, so 14 plus x. Is that bigger than 7? Okay, well here's a situation where 14 is already bigger than 7. I don't need to add anything to it, so that becomes a moot point. I don't need it. Add the first and the last, see if it's bigger than the middle. Solve this. X is greater than 7. Okay, so here's your two inequalities that you're going to use. So my final answer, smaller number, less than sign, variable, less than sign, biggest number. And that's my answer. Take a second and try 18 and 20. See if you can get the answer. Pause the video. Okay, take a look at 18 and 20. If you've got any questions, don't hesitate to ask.